Today we're going to talk about the three-phase AC motor nameplates, the induction motor. First we need to know a little bit about the actual frame size. The frame size back in 1952, they were what's called Pre-nema. Physically these motors were very large. And the reason that they were very large was due to the fact that our insulation systems weren't very good. The motors had to run very cool. And since they were running very cool, physically the motors had to be large. Then in 1962, we changed to a U-frame motor, which in some areas are still very dominant. But physically what they did is they made the Pre-nema a little bit smaller. Then they went to the T-frame. And the T-frame physically made it smaller again, and then we went to the IEC, or the International Standard, which are the metrics. NEMA is the National Electrical Manufacturers Association. They're the ones that determine what physical size all these motors are going to be. Our shaft dimensions, our bolt holes, so that way from one manufacturer to another, we're going to get similar motors that can be bolted back up into an existing, and you're not going to need the original manufacturer's motor. We've got an F1 design is your standard right out of the box when you call for a motor. The F1 design, looking at the shaft, your junction box is going to be on the left. That's your standard F1 design. Then we've got our F2 design. Now if you're calling for a motor and you need an F2, it has to be specified. The F2 design, depending on where your physical leads are coming into the motor. An F2, looking at the shaft, your box is going to be on the right. Sometimes how tight your machine actually is, you're not going to be able to use the standard. Then the other thing that we've got is back in the day, the original manufacturer, the motor manufacturers, would go ahead and they would put C-faces on, they would put D-flanges, they would put brakes, and all this would be specified on the actual motor nameplate. Now the way the manufacturers do it is they sell the OEMs, the original equipment manufacturers, and the motor shops the actual C-flange or the D-flange or the brakes, and those have to be modified by the OEM. A lot of times the nameplate is not modified, so you need to see what an actual C-face is, so you know what you're going to be ordering. If you order this motor in the middle of the night, or you're running across country in order to get it, and then you get it and it doesn't have the right options because somebody hasn't modified the nameplate, it could cause some big problems. Then we've got the C-flange is going to be your like a 1 horse would be a 143 TC is going to be the C-flange. The D-flange would be a 143 TD. Now the difference between a C-flange and a D-flange, the C-flange, when you're bolting up your gearbox or your pump or anything, the actual mounting bolts are going to be screwed right into the motor flange itself. A D-flange is physically larger in diameter than the size of the motor, and the bolt actually goes through the flange and then screws into what your gearbox or your pump or whatever you're mounting it to. Then we've also got a brake motor, which the motor on the back will be like, say, a 143 TY or a TCY. That's a brake, is mounted on the back of the motor. And then we've also got, if you're trying to order up a Z frame, is all the Z tells us is that it's some type of a special shaft. The shaft itself could be longer, could have a little knob on the end of it, could have multiple steps, it could have double shafts. All it's telling us is that there's something special to that shaft. And we'd need more information to actually get you the motor that you need when you run into a Z-frame. The other thing that's very critical on a motor nameplate is the new IEC motors, or the international standards, which are metric. are all in kilowatts. In the United States, we're used to using the horsepower. Well, in the IEC, they use kilowatts. There's 746 watts per horsepower, which is very important. So that way, if we're looking at a motor that's got 1.5 kW for our current, we know that we're looking at a 2 horsepower motor. So there's 746 watts per horsepower. I think that gives us kind of a pretty good idea. The other thing you kind of got to watch with motor nameplates is make sure that you're looking at the 60 cycles rather than the 50 cycles. We've got what's called synchronous speed in the United States with 60 cycle motors. We're going to our synchronous speed, or the speed of the stator's rotating magnetic field, on a 4-pole motor would be 1800 RPM. On the actual motor RPM would run somewhere in the neighborhood of like 1750, 1725. On 50 hertz, that speed is going to be down to 1500 RPM. So then you'd have your actual motor speed would run right in the neighborhood of around 1450. So if you're calling for a motor, you need to make sure, if you're looking for 60 hertz, that is the actual speed that you're going to be looking for.